So in one of my most recent projects, I built a flight computer which actually has thrust vectoring capabilities. And with that, it brings a lot of dependencies, such as the PID gains and a lot of flight settings that have to be on board at all times and it can't change. And sometimes you just don't want to change it every time you reboot the system. And so this is a quick solution. And what I've done here is basically I've added an EEPROM where I can program and add flight settings to using this potentiometer, a button set, and a switch. So what I'm doing here is I'm just replacing the processor of my flight computer with the Arduino because this is basically the same thing that's running. And I'm not using these two sensors down here, nor the buck converter in this corner, just this section. So what I'm doing is there's a little switch here which either goes in debug mode or flight mode. So flight mode is low and debug mode is high. And then when it goes on debug mode, you'll need to jump one of these pins. So one of these are actually the servo angle set. So let's say you want to eject your parachute with a servo motor right outside here, and you want to set it at a certain angle that it opens at. Well, if you kind of jump or short the jumper pin that is in control of the servo angle, then you can set with your potentiometer the angle you want to do. You press the button to set it into the EEPROM and it saves. And then you just turn off the debug mode whenever you're done. And so now when you reach apogee, after a certain delay, it'll rotate the angle, it'll grab the data from the EEPROM and then send it out to your servo motor. And I also mentioned the delay function, so you can just go down here. I actually programmed the second pin, or if you jump that one, you can actually set a delay duration after apogee detection. So that's what I want to show you right now. So I'm just going to plug in the power. And there you go. And so currently you see that there's a jumper, and right now it's connected to the, I believe that's the delay pin. So if I turn this on and I rotate the knob, it actually set from 0 to 10 seconds of delay after apogee. So right now I've had a maximum, and when I press the button, well, right now it just saved 10 seconds to the EEPROM. And I can now change, for example, the angle of your servo motor. And so what I have to do now is I take the jumper, if I can get it out here, and I jump the servo pin. Now it's connected to the servo. Now I don't know what's, it's kind of bugging out here. And if I turn it, you see that it turns the servo. Now there's clearly some debugging going on, some jittering, and I'll have to look in the program for that. Definitely a software problem. But you get the general idea where if you can set the angle like this, and then you press set, and then it sends to the EEPROM. And then you just turn it off whenever you're done. I also recommend removing your jumper for flight. So now you don't have to worry about anything. And for those who are curious on, well, what happens if this goes high during flight? Well, the good thing is that this is reading off a digital pin, so you can just ignore the value that's coming up to the digital pin during flight. So if you have a launch attack system, well, you could just ignore if it's a high or low, and then you won't have to worry about anything shorting out. And I think this is a quick video on just the use cases of EEPROMs for in-flight configuration. Thanks.